Oh, and I need someone to check in with and make sure 44 is in front of you. Everybody should make sure 44 is in front of you. Who can I check in with for 44? And that already has it in front of them. The actual question. Need someone to check in with? I gotta get 44 in front of me too. Where is it? Oh, there it is. Who can I check in with for 44? All right. Okay. So 44, we've got these two blocks, and we got these two blocks, and this force P, which I just picture as like somebody having a rope pulling on the big block. And what they're doing is they're pulling on this block such that this other block doesn't slide down. Is that okay? That it could stay there? Okay. How could it stay there? We'll get to that in a minute if you haven't made the connection of what's going on with friction or haven't read the problem in a little while. And they give us some information here. They tell us mu sub s is 0.71 between these two blocks. So mu sub s is 0.71. And then I think they say this surface is smooth or frictionless. Is that correct? This surface is frictionless? All right, so this surface is frictionless and this other one isn't. Or it's relatively close, right? It's good enough for an approximation here. And they ask us to find, they probably tell us the mass of the block too, right? Yeah, mass of the block is, mass of the small block's 4, big block's 25. So this guy is 4 kilograms and this guy is 25 kilograms. When you get a tough problem and you get stuck, again, there's lots of ways to help get unstuck. One is to go back, reread the question, and start adding stuff to your picture or listing knowns and unknowns to help you realize what's going on in the problem. I like to add it to my picture when I get stuck or if I know I'm doing a hard problem. So 25 and 45, and I'm going to, for the sake of notation, call this block 1 and this block 2. Are you okay with me calling it block 1 and block 2 going forward? I could also call it the 25 block and the 4 block or A and B or big, small, whatever. But I'm just going to use 1 and 2. Is that okay? All right. And I'm going to draw free body diagrams. Oh, let me get what we're asked to find. We're trying to find, it says, okay, a small cube is in contact with the front surface of the large cube and will slide downward unless P is sufficiently large. The coefficient, blah, blah, blah. What is the smallest magnitude that P, this force P that's pulling on the big block, can have in order to keep the small cube from sliding downward? So we want P to be the smallest value without this thing moving. Right away when they start to say something like smallest or greatest and friction's involved, I start to consider what kind of friction I'm going to be dealing with. If we want P to be as small as possible, that means to keep this block up, we're going to use as much friction as we possibly can. Does that idea make sense? All right. So I'm going to draw free body diagrams now for these two. So I'll draw a free body diagram for block 1, and I'll have, this is the normal force on block 1. So I'm going to use Fn1 to denote that's the normal force on block 1. And the weight of block 1 going down. And force P, which I would just leave as P because they already defined it. That's it acting on, oh no, that's not it acting on block 1. Sorry. What else is in contact with block 1? Yep. Block 2. So I'll have block 2 acting on block 1 this way. So force of 2 on 1. Is that okay? Because they are in contact. So it's going to push. It's got to. All right. Now I'm going to go to block 2. And I'm going to draw a free body diagram for block 2. And for block 2, I'll have the weight of block 2 going down. And I will have friction going up. Why is friction going up? Because block 2 is trying to slide down. So the thing that's going to keep it from sliding down is friction. What kind of friction? If it's not moving, it's certainly going to be static. And then since we have this idea that P has to be the smallest, and this thing's just about to slide down, we're going to use all the static friction we can, so I actually do get to write force of friction static max. Now, what's also in contact with block 2? Block 1. So we have this force of block 1 on block 2. Are you all right with both free body diagrams? I'm going to add some stuff to the free body diagrams to make our algebra life a heck of a lot easier. But before I do that, take a minute and think about each of these free body diagrams. Oh, and these are, by the way, equal magnitude and opposite in direction. And even if I was abbreviating, I am abbreviating. You were supposed to still not be when you did this problem originally. Now, if you want to abbreviate, you can. Okay. This is our last problem in chapter 4. So, but even if I was abbreviating, which I am in this problem, I have abbreviated everything else, I would still write these out as 1 and 2 and 2 on 1 because it's going to help me solve the problem. Okay? Anytime you have Newton's third law going on, that's when it really helps to write the stuff out. Question? Oh, no. You think you're okay with both free body diagrams still after thinking about it? Anybody else have questions on any one of these forces and like why it's there? Because I will re-explain. This is certainly different than most of the free body diagrams you looked at. Okay. Well, this force of 1 on 2, is due to a perpendicular contact force. Here's what we normally see for the normal force of the pen. Well, if I take it and turn it into a vertical wall like this, now the normal force, if there is one, if we're in contact with the surface, it would point straight to the right. So if this pen's trying to slide down, the normal force is actually pointed straight to the right. So this 1 on 2 is the same thing as the normal force. And I'm just going to call that F sub n2, I guess, to avoid any confusion. So that's force of normal force on 2. And that is the same thing as 1 on 2. That's the normal force for block 2. Is that okay? Yeah. All right. That means this is also the same thing as the normal force on block 2, except it's going the other way. We'll deal with the signs here in a little bit. Let's start to sum forces. I'm looking for force P, so I'm going to start there. So I'm going to sum forces in the x direction on block 1 will be equal to the mass of block 1 times, I could write the acceleration of block 1, but these two blocks are stuck together. Their accelerations will be the same. So it's sufficient to just call it acceleration of either one. They're all the same. A1 equals A2 is what I'm saying. A1 equals A2. The acceleration of this block and this block are the same. If I'm running so fast that this thing sticks to my hand, right? If I run really fast and this sticks to my hand, my acceleration is the same as this block's acceleration. Is that okay? Everybody else, is that all right? When two things are stuck together, they'll have the same magnitude of acceleration and oftentimes the same direction as well. If the rope's going around a corner, you got to be careful. But okay, so I'm just going to call this A to avoid an extra variable. How many forces in the x direction? 2. So I'll have P minus this F2 on 1, which I'm taking care of the sign right now, so I can just go ahead and I'm going to call it Fn2. Make sure that that makes sense. Yes, equals M1A. Are you okay with me? Let me make that a little bit more legible. It's not a W, it's an N. Are you okay with me going ahead and just saying the magnitude of this is Fn? All right, and it's going to the left, so I put the sign on right here. Well, now I'm really stuck because while I know the mass, I don't know the normal force on block 2, and I don't know the acceleration. So I'm definitely stuck at this point. So I'm going to keep summing forces like crazy. Let's see, if I'm looking for the normal force on block 2, now I think I'm going to sum the forces in the x direction on block 2, and we'll see what happens. Summation of forces in the x direction on block 2 equals M2A. And I've only got one force. I've got this normal force equals M2A. Well, I know M. I still don't know A, and I still don't know the normal force. So I've written another equation, and I still have the same number of unknowns, so things are getting a little bit better, but I don't think I have enough to solve. Because here I have, here I have 3 unknowns. Here I have 2 more of the same. So I'm still at 3 unknowns with how many equations? 2. So I need more. I need as many equations at least as I have unknowns. So I'm going to go ahead now and sum forces more. Well, what's the thing I don't know that I can still sum another equation for? Well, if this acceleration was in the x direction, I'm going to put some x's on that. Just so nobody gets confused if they look at it later. This is the acceleration in the x direction. So I'm not going to sum. There's nothing else to sum in the x direction. P is what I'm trying to find, so there's nothing to do there. So the last thing that I could look at is the normal force. Well, what other equations have normal force in them? The equations for friction. So I'm going to write the equation for friction and see if that helps me out. So force of friction static max equals mu sub s times the normal force where we have the friction. So this static max right here, okay, that's the mu sub s that we were given. So we're okay with that. And I think we might have enough now. Nope, we don't, because I've added a variable. I added another equation, but I added another variable. So I'm still stuck. Are you with me that I'm still stuck? Questions before I... Yep, go ahead.
Where did you get the equation? Sorry, I just blinked out.
For static friction?
Yeah.
This is one of the given equations.
Okay.
Now, it's not like this exactly in your equation sheet, but we're doing these problems.
Okay.
You can draw a picture, free body diagram, and sum forces, and then there's these other relevant equations. The other equations we have are an equation for gravity, equations for friction and motion equations.
Okay.
So I went and wrote an equation for friction.
Okay.
This is not specific to this problem.
Okay, that makes
Well, it's specific once I put on normal force too.
Okay.
But static max always equals mu sub s times the normal force for whatever object you're looking at. Is that okay?
Yeah.
All right, so I'm still stuck. So now I'm like, okay, well, static max. I can write an equation with that in it. Static max here is in the y direction. So I'm going to sum the forces in the y direction on block 2. And now I'm doing this in somewhat in a logical order, but even if you had no idea what to do here, if you just started summing forces like crazy, eventually you would get to enough equations, enough unknowns. So when in doubt, just keep going and keep working and hope that you'll get enough to solve the problem. Okay? So in the y direction, we have on block 2, 2 forces. So a force of friction static max up minus the weight of block 2 going down equals m2 times a. But what is my acceleration in the, I should put this on here for clarity, what is my acceleration in the y direction on block 2? 0. I think that's the mistake I made the last time I posted this to YouTube. Like the video cut off, and then I was like at the board still talking to nobody in the room. The camera wasn't even rolling anymore, and I was like, oh, this should be 0. Okay, are you okay that this is 0? Okay, so I'm going to just go ahead and put in a 0 right now. And now we're in business, because I can calculate the weight of block 2, which means now I know force of friction static max. Yes?
Okay, just for clarification.
Yep, go ahead. Why is it 0? Oh, because this block, okay, here's the picture. Pretend this is the block. I'm the big block, this pen's the small block. Here's what's happening. It's not moving up or down. This is in the y direction. This is in the y direction. The y direction. Yes?
Are we assuming up and right is positive?
Yes. Yep. As soon as I did this with a negative and that with a negative, up and right's positive. And I will assume that from chapter 4 onward. So you can abbreviate, and I will assume up and right's positive from chapter 4 onward. Where was I? Okay, yeah, so this is the picture. It's not moving up or down at all. It's just moving. It's just accelerating to the right. Is that okay? Because of the setup, they said it's not slipping down. P is just big enough to keep this from moving down, which means it's not moving in the vertical. All right, and now I think we have enough to solve. So we have enough to get static max. Or excuse me, we have enough to get, and, oh, wait a minute. Yeah, we have enough to get static max, which means this is something we know now, which means we can get the normal force. If we can get the normal force, it looks like we can get A. If we can get A, and we can get the normal force, we can get P. So now it's a matter of just doing a heck of a lot of math. So before I do that, and you could do this with variables. I'm not. I'm going to substitute in numbers and take the numbers through. But you could just keep substituting variables. That's what the key does. Before we do that, though, where do we have questions? I will put some magnets down here because I don't want to number them. All right, so the Hershey Kiss is this part. Peanut Butter Cup Dude's there. The circular old school magnet from Hardcore Science way a long time ago, right there. Friction will be the red-green magnet. Free body diagrams are free body diagrams. Where do you have questions? Hershey Kiss, Peanut Butter Cup, circle, red-green magnet. Just tell me and I will re-explain. You can even just say, just Hershey Kiss and I will go and I will re-explain everything about it. As always, it's one thing to follow this. It's another to be able to do it on a test. Good news is, if this was a free response question, they would break this into part A, part B, part C, part D. So you wouldn't have to just, they kind of lead you to it a little bit. Also, at this point, they might, if they didn't break it into multiple parts, like if this was part E of a question or something like that, it might be set up such that it could be solved, and they wouldn't even give a point for doing all the algebra. It would depend. Questions before we solve. Okay. Let me go ahead and plug in all the numbers. I'm going to actually stop the video because that's the end of the physics. Now it's just a matter of a bunch of substitution, and I'd like this to be as short and accessible as possible. You can check the answer in the key.